There we go.
So who here likes Saturdays or Christmas? One day a week where you don't need to physically come into work. Well, for many researchers who work with induced pluripotent stem cells or iPS cells, this is not possible. My name is Sherry Biandera, and I'm a graduate student who does iPS cell research.
My name is Lindsay Andrews-Beck, and I'm a grad student who used to work with iPS cells.
We're here today representing CSquared Solutions. At CSquared Solutions, we focus on automating the cell culture process.
It's not going. Okay. Nope. Click it. Okay, I'll just stand here. Sorry, guys.
One of the challenges in this arena are the owner's maintenance needs of cell types such as induced pluripotent stem cells, which require at minimum media changes 7 days a week, regardless of weekends or even holidays. This is a quality of life issue for many of the researchers who work with this platform. It can also pose a barrier to those interested in adopting induced pluripotent stem cell work.
At CSquared Solutions, we work to improve the cell culture process through the use of simple, automated platforms. Current cell culture automation systems are large and cost prohibitive, making them impractical for the average academic research lab. It doesn't have to be this way. The technology is now in place to provide a more appropriate and cost-effective solution. And by designing products that automate media changes, we will enable new labs to join the arena, reinvigorate current scientists, and accelerate the rate of stem cell research. Our first product is a self-contained system that automatically performs media changes without needing to leave the cell culture incubator. This system mounts on a standard 6-well plate and uses fluid controls to exchange depleted media for fresh. With our product, you can finally spend Christmas at home without freezing down cells and losing weeks of research time. You could take 1 day off to recuperate and prevent burnout, and you could even stay home the next time a bad blizzard is going to hit Minnesota.
So addressing these needs will tap into the global market for stem cell research products, a $1.2 billion industry, as well as the cell culture market, which is projected to reach $11.3 billion by 2020. Given that the volume of cell culture media consumed was projected to increase by 11% just last year, there'll be an increasing need for companion products and automation for this process. This provides the perfect opportunity for us.
We hope you'll join us in making this vision a reality. We are CSquared Solutions. Our product works, so you don't have to.
Hey, that was awesome. We had a really good conversation earlier for all you guys that don't know, so this might be out of nowhere, but I think it's first of all amazing that you guys started with a personal need that you all have and then are rapidly prototyping a solution to try and bottom up get to a market. So could you just tell the audience a little bit about what you just passed along to the Walleyes?
Yeah, so what we passed around is actually our first design prototype, and over Christmas break we're going to try to build the functional part. But it's essentially the box that's going to contain the electronics. On the bottom is a section that's going to connect to tubing that's going to go in and actually, pull up and take down the media.
Fit on a 6-well plate.
And it fits on a regular 6-well plate, which is on the bottom there. It's the clear part, and our prototype is the white part.
And then the top part has the reservoirs for the depleted and the fresh media as well. And in this particular model, you can put the top of the regular plate on top of that.
So, question, great presentation, by the way. So this is the disposable component. Is there a larger capital purchase component for pumps or what have you? Or is it compatible with existing equipment in the lab?
The general idea is that the essential component here where the electronics and pumping mechanisms will fit would be a reusable part that you could sterilize. And then we would have disposable components as well. That would probably be about similar to what you buy for a normal plate. Yep.
Okay, good.
To help minimize any contamination, which we know is a huge issue.
And just to be clear, this is for media exchange, so splitting cells when they're confluent and stuff. That's this.
No, yeah. So this is literally the stem cells and a couple other cell types need to have their media changed every single day, without days off, unless you want to freeze down your cells to take a break or go to a conference or etc. And so this is just a media change solution.
I guess it might be cell specific, but so if you use this, is that a 1-day usage, or could you do multiple days? It depends on the growth rate of the cells, I suppose.
So our idea is to have this at this point in time be able to hold enough media for a couple days worth of changes. But I mean, you could potentially reuse it
and if your cells just needed to have their media changed every other day or something, you could set it to do that. But the main pain point is our field, stem cell research, where it needs everyday attention.
And sort of dominate the panel here, but one last question. Have you looked at intellectual property protection? Is this patentable? Is it unique? Is it novel?
So there is one device that's patent pending, which has a similar concept in design. It's quite different from this, and we can't find their patent online.
Since it's not been granted yet.
Yeah. So.
But there's no other product that's this exact kind of idea.
One final quick thing. So the market, if I'm clear, I'm not an expert in stem cell stuff. The market is colleges, universities, research institutions, not so much the private corporate market, or no?
So for our first steps, that's the plan, is that this device and devices in this early generation is going to be targeted towards academia, but the next generation device would be a bigger platform that we'd like to work with companies, especially places like Regen Theranostics that are local, to try to make that happen.
Okay. Thanks.